All right, this is section 8.1, volume of cylinders. And now that we've done the volume of rectangular and triangular prisms, it won't be that much more difficult to throw in the volume of a cylinder. And so we said in our last lesson that the volume of any prism is V equals capital B times H, where capital B stands for the area of the base. So a cylinder is actually going to use that same formula because a cylinder is just a circular prism. So the area of its base, because it's a circle, is just going to be pi r squared, which is how we find the area of a circle. So the three main types of prisms we've looked at so far: rectangular prisms uses the formula V equals capital BH, where capital B, because it's a rectangle, is going to be length times width. And a triangular prism, capital B, because it's a triangle base, is going to be 1/2 BH. And on a cylinder, because it's a circular prism, we're going to use pi r squared. So we're using the same formula each time, we're just using a different area formula for capital B. So let's look at this first cylinder here. It says find the volume of the cylinder, write your answer in terms of pi, and round it to the nearest tenth. So because it's a prism, I'm going to use the formula V equals capital BH, but because it's a cylinder and my base is a circle, I'm going to use pi times the radius squared, and the radius in this circle happens to be 4. Now the height is going to be the distance between the two circles. Remember, height doesn't always have to go up and down. It's going to be the distance between my bases, and so that's going to be 15. And so to write my answer in terms of pi, I'm just going to multiply everything I can multiply together without multiplying by pi. So that's going to be the 4 squared part, which 4 squared is 16. And then 16 times 15 is going to be 240. So my answer in terms of pi is just 240 pi. But it does want me to also approximate my answer to the nearest tenth. And so that's where I'll just go ahead and multiply by 3.14. And 240 times pi, or 3.14, is 753.6, and we're doing volume, so we're using cubic units, so feet cubed. All right, let's do that again for this next example. Again, it's a cylinder, so it's going to use the formula V equals capital BH, the prism formula. But because it's a circular base, I'm going to use my circle formula, which is pi times the radius squared. And remember, the radius is the distance from the middle of the circle to the outside of the circle, and we're given that here as 3. The height of the cylinder is going to be 6. So 3 squared is 9, and 9 times 6 is 54. I can do all that in my head, so all I have to do in my calculator is to take 54 times 3.14, and that's going to give me 169.56. But it wants us to round to the nearest tenth. So 169.56, the 6 is going to bump the 5 up to a 6, so I'm just going to make this 169.6 meters cubed. And then for example B over here, again I'm using the same formula, V equals capital BH, my cylinder formula, and prism formula, and then I'm going to use pi r squared because my base is a circle. And this one, they're trying to throw you a bit of a curveball here by giving you the diameter. And we don't want the diameter when we're finding area. We want to use the radius squared. So we have to take the diameter of 3 and divide that by 2, and that makes our radius 1.5. And so pi times the radius squared means pi times 1.5 squared. And then the height is going to be the distance between the two circles, which happens to be 3. So 1.5 squared is 2.25, and 2.25 times 3 is 6.75. I'm just going to write this down since I've done a few steps already. And then I'm going to take 6.75 and times that by 3.14. And so that's going to give us a volume of 21.195. But just like last time, I'm going to round to the nearest tenth. So that 9 is going to bump the 1 up to a 2. So we'll call this 21.2 meters cubed. So again, I'm just finding the area of my circle part, which is different on both these, and I'm timesing by the height of the cylinder. All right, for this next example, they're going to want us to find the height of the cylinder. Normally, we are given the height, and we can find the area of the base, and we just multiply those together to find our volume. But they're wanting us to find the height, and so I'm going to use my volume formula of area of the base times the height, but this time they're actually telling me the volume is 176, so I'm going to plug that in for V instead of plugging in for H. Now the capital B I can still find. Capital B is going to be the area of this circle right here. And so that's going to be pi times the radius 4 squared. The radius is 4 because they're giving us the diameter of 8, times h, which we don't know what h is. But we can find out what pi times 4 squared is, because 4 squared is 16, and 16 times pi is 50.24. So I've just figured out what pi times 4 squared is. It's 50.24, and I'm going to times that by h. But I'm going to have to work backwards here. Anytime I have to find a missing length or a height, I end up working backwards. And so to get h by itself, we're going to get rid of this 50.24 that's being multiplied to the h, and we're going to divide both sides by 50.24. So 176 divided by 50.24 is going to give me 3.5. Okay, so we're supposed to round to nearest tenth, and it's 3.50, which is going to leave that right at 3.5 centimeters. And we're just going to use centimeters because we're just finding the height of the cylinder. We're not actually finding the volume because we already know that. So I'm not going to use cubic centimeters when I label my answer. So to recap, I plugged in 176 for the volume, plugged in pi r squared for the capital B. We found what pi r squared was. It was 50.24. And we just divided it over because we never knew what h was. And then so by dividing it over, we find out that the h is going to be 3.5 centimeters. All right, I want to go over one more problem that's like one of the ones on the homework. So I want to throw an extra one in here, and it says, how many gallons of water does the water cooler bottle contain? Round your answer to the nearest whole number. And so that's important. I'm going to underline that because this is the first time they've asked us to round to the nearest whole number. And so really what I'm doing is I'm just finding how much space is inside the water cooler, and because it's a cylinder, or mostly a cylinder, I'm going to find the volume of this cylinder. So it's got a circle base. I'm going to try to circle that for you so you can see it. It's got a circle base. And when it tells us that one side of the circle to the other side of the circle is 1 foot, that's giving us the diameter. So if the diameter is 1 foot, that's going to make the radius a half a foot, so 0.5 feet. So my volume formula is V equals capital B times H. And so because it's a circle, pi times the radius, 0.5 squared. Or I could write 0.5 if that's confusing. So pi times 0.5 squared. And then the height of the water cooler is 1.7 feet. All right, so let's start by squaring the 0.5. 0.5 squared is 0.25. And then if I multiply that by pi, that's going to give me 0.785. So the area of my circle is 0.785. Now I have to times it by the height of the cylinder, which is 1.7. A lot of decimals here. And that's going to give me 1.3345. And so I get 4 decimal places. I'm not going to round just yet because I have one more step that I have to do. This is measured in cubic feet. But when we talk about water, we usually don't talk about how, cubic feet of water. We're going to talk about gallons. And so this is what's important here. Each and every single cubic foot is 7.5 gallons. So if I've got 1.3345 cubic feet, and each of those is 7.5 gallons, I'm going to multiply that by 7.5 gallons, and that's going to give me my number of gallons, which is 10.00875. But remember, I'm supposed to round to the nearest whole number. So I'm just going to leave that as 10, and instead of labeling it in cubic feet, we're going to label it in gallons. So each of these water coolers holds approximately, and really close to, 10 gallons of water. All right, let's look at some homework problems now. I think I've got 3 of them here that we can look at, and the first one is number 14. And number 14, just like one of the last problems we did, we have to find the missing height of this log. So because it is a cylinder, I'm going to use the formula V equals capital BH because it's a circular prism, and because it's got a circle base, we're going to do pi r squared. And the radius of this log, if the diameter is 32, that would make the radius, which is just half of that, 16. But I don't know what the height is. Instead, I know that the volume is 10,000 pi. So I've got 10,000 pi equals pi times 16 squared times h. Now, I'm not actually going to find out what 16 squared times pi is. I'm not even going to do 10,000 times pi. Both of these problems have a pi on, or both these numbers have pi on both sides. So what I can do is I can start by dividing both sides by pi, and what that's going to do is it's simply going to get rid of those 2 pi's. So I don't have to do any timesing by pi at all. Because each time has a pi, each side of the equation has a pi, I can get rid of the pi on both sides, which leaves me with 10,000 equals 16 squared, which is 256, times h. And so just like before, we're going to take 10,000 and divide by 256, and that's going to give us 39.0625, but it says the nearest whole number. So 39.0625 is just going to approximate to 39 inches. Again, because it says the nearest whole number, and that's a lot closer to 39 than what it is to 40. Number 15 is a similar problem. This time, instead of missing the height, we're missing the radius, but it's asking me, or it's giving me the volume of the cylinder, so we'll use our volume formula. And then we're going to plug 600,000 in for V. Now notice there's no pi with this one. And then the area of my base is going to be pi times the radius, which I do not know, so I'm going to leave it as r squared, times the height, which the height of the cylinder is the 76 centimeters that we see right there. So unfortunately, I'm not able to cross out that pi because the other side, the 600,000, does not have a pi on that side. So what I'll do first is I'll get rid of this 76 by dividing both sides by 76. All right, so when you divide 600,000 by 76, you get a really long number. It's 7,894. And then it's got a ton of decimal places. So I'm just going to use, I think, just 3 of them right now. 7, 3, and then it's 6, 8. So I'm just going to call that another 7. And so that's what we get when we divide by 76, which just leaves us with a pi r squared on the other side. So the next thing I'm going to do, after I divide by 76, I'm going to get rid of the pi. I'm going to divide both sides by pi, which is 3.14, which is going to give me an even smaller decimal. I'm sure it's going to have a ton of decimal places. So when I divide by pi, I'm going to write this up here. On each side, now it's 2,514.25. We'll just use 2 decimal places for this one. And that's what I have on one side. And then the other side is just r squared now, because now there's no pi, because I divided by it. And so what I need to do now to get rid of the squared is not to divide by 2, but you might remember doing this. The opposite of squaring a number is square rooting it. So somewhere on your scientific calculator, you have a square root button. And so if you hit the square root, again, what we're trying to figure out is what number times itself, right? The radius is being times by itself. What number times itself gives me 2,514.25. So when I square root that number, I'm going to get r to be 50.1, but it does say the nearest whole number again. So that's just going to be closer to 50 centimeters for the radius. All right, and then the last homework problem I'm going to look at is number 17. And number 17, it says a traditional square bale of hay, like the kind that you would typically sit on in a barn, is actually in the shape of a rectangular prism. So it's going to look something like that. Little square bale of hay right there. Its dimensions are 2 feet by 2 feet by 4 feet. So sometimes drawing a picture can be helpful. It says how many square bales, how many of these bales would contain the same amount of hay as one of these larger, rounder bales that we see over here. And so what I need to do is I need to find the volume of this particular bale of hay, the square bale that they're calling. And so that's 2 times 2 for the area of my base times 4. And so 2 times 2 times 4, or 4 times 4, is just 16. So these square bales of hay have a volume of 16 cubic feet. And I want to know how many of these square bales of hay, these are the square ones, how many of these would fit into the circular one that we have over here. And so for that, I'm going to need to find out what the volume of this circular bale of hay is, and that's a cylinder. So I'm going to do pi r squared, which my radius would be half of 4, which is 2, times my height, which is 5. The distance between the two circles is 5. So 2 times 2 is 4. Squaring 2 is give 4. And then 4 times 5 is 20. So we have 20 times pi. And 20 times pi is 62.8 cubic feet. So if I want to know how many square bales would fit into this circular bale, or round bale, I guess they're calling it, then I need to divide to figure out how many 16s will go into 62.8. And so I'm going to do 62.8 divided by 16 to figure out how many of these square bales would fit inside that cylinder. And I get 3.925. 3.925. And it says round your answer to, again, the nearest whole number. So we're going to say that's closer this time to just 4 square bales. Or you could just say 4 bales of hay there. So 4 of these rectangular bales here, 4 of these would fit into one of those.